Faulting or faults occur when there is a crack, fracture, or breakage zone in the Earth's crust and slippage occurs. As you can see in this diagram, there are four types of faults. Those four types of faults are the normal fault, the reverse fault, the thrust or overthrust fault, and the strike-slip fault, which is very similar, of course, to transform movement within the concept of plate tectonics theory. Let's start with the normal fault, shall we? These are the result of tensional forces, which means the crust is pulling apart, as you can see indicated by the arrows. The movement is overwhelmingly vertical with normal faults, which means up and down. Fault scarps are common. Fault scarps are a cliff that's created along a fault line. You can see the fault scarp being created right here as a result of the fault movement. And it results in stretching the crust out. The Teton Range in Wyoming is one of the great examples of movement along a normal fault line. You can see on the right-hand side where the mountains are rising along this normal fault. And then you can see where Jackson Lake is at, which is a part of the Snake River system. This is dropping down along that normal fault. You can really see that normal fault displacement here. In many places where you have a series of normal faults, things called Horsts and Grabens are created. A horst is a block of land that's lifted between normal fault lines. So it's lifted between them, which you can see in this kind of slightly fuzzy diagram. Sorry about that. That's the way it goes. This, of course, makes a mountain. And a graben is a block of land that drops down between normal fault lines, which again, you can see these blocks of land dropping down, making a valley between the normal fault lines. This is what happens in the western part of the United States, where we have what's known as the basin and range system, where as a result of tensional forces, the crust pulling apart, cracks happen in the crust, and then you can see the result of that is that horsts and grabens begin to form. Basin, the drop-down area, the graben; range, the lifted up area, the horst. Death Valley is a great example of a graben. You can see the arrows indicating that block of land dropping down between normal faults. And in fact, Death Valley is the lowest point in the entire Western Hemisphere at 282 feet below sea level, which is right about where you see that salt flat on the bottom left-hand side of this particular photograph. It happens that the Sierra Nevadas and Owens Valley are also being moved around along normal faults. If you take a look, you can see the red arrows indicate the uplift. You can see the Inyo White Mountains are a horst. However, the Sierra Nevada is not a horst. It's a tilted fault block mountain, but it's only tilted on the eastern side indicated by the red arrow. So that lifts that eastern side up, which causes a very gentle western slope, a very steep fault scarp on the eastern side. And then you can see between the Inyo White Mountains and the Sierra Nevada is Owens Valley, which is a graben dropping down between two normal fault lines. This is a photograph, a really beautiful photograph of Owens Valley, which you can see running through the middle and is dropping down into this graben, and at the same time, over across the valley, the top of the photograph, you can see the snow-capped mountains. That's the Sierra Nevada, which is being lifted along a normal fault line. That's the eastern slope of the Sierra Nevada. Reverse faults are the result of compressional forces, as you can see indicated by the arrows, where what happens is the blocks of land are shoved together. The movement, once again, is primarily vertical, so upwards. Fault scarps are common, so you get cliffs with these, and this causes a crust to shrink or be shortened as a result of the two blocks running into each other and one kind of riding over and the other riding under the other. Where? Well, the transverse ranges in California, which is the San Gabriels, the San Bernardinos, San Jacinto Mountains. You can see there they are in the background. That's the San Gabriel Mountains, taken almost from my house, actually. The thrust or overthrust fault is also the result of compressional forces. And these tend to be complex horizontal and vertical movement. They're basically a low angle reverse fault. You can see a reverse fault on the left-hand side and a thrust fault on the right-hand side. Really, the difference between them is angle. Reverse fault is a very steep angle. A thrust fault is a very gentle angle. Do they make fault scarps? Well, sometimes, but not always. The Alps and some parts of the Rockies are formed this way. The last fault is the strike-slip fault. This happens where you have horizontal movement. In other words, the blocks slide next to each other, as you can see in this diagram. Fault scarps are uncommon, and as we know from the earthquakes lab, this is the San Andreas Fault, where the North American plate and the Pacific plate slide alongside of each other. You can see right here, once again, the San Andreas Fault indicated with the red line on the map of California, and that you can see in one of the most famous places where you can see the San Andreas Fault and the Carrizo Plain, this crack that is indicating this division between the North American and the Pacific plates, and also a strike-slip fault.